welcome to today's session on basically the latest geospatial features in Oracle Analytics. And for those who don't know me, my name is Ramu. I'm a product manager for spatial and graph technologies at Oracle. And we're going to have two speakers today. We have Denise Myrick. She is also a product manager and she will be introducing herself. And we also have Gautam Pisharam, that is a senior solution engineer. So very excited today. We do these ASM sessions on Oracle Spatial Technologies every last Tuesday of the month. So the next one is going to be April 29th, and we'll update you on the topic whenever we have that. But make sure you mark your calendar if you're interested in these sessions. All of our sessions are recorded, so basically this one will also be recorded. And for you to find these sessions, you can just go ahead and search under the videos tab in the Ask Tom website and filter series, or basically select spatial for DBAs, analysts, and developer office hours. And you'll be able to find all of the previous recordings in there. And if you have any questions during the session, please go ahead and enter them in the QA box. You should be able to find that under your Zoom window. And if you're not able to find it, please send me a message through the chat and I'll be able to guide you through. So let's go ahead and introduce Denise. She will be the first presenter. So Denise, whenever you're ready, you can go ahead and start sharing.
Hi, good morning, good afternoon, everyone. Thanks for being here today. So today I'm going to do something a little bit different. I'm going to show how we could use Oracle Spatial to do something in our personal lives, and hopefully you can use that to apply it to your particular use case and your business. So I have a small son, he's 2.5, and so I have the privilege of trying to find him a daycare that fulfills some certain requirements, right? So it needs to be close to where we work, my husband and I, close to where we live, and if we're lucky, close to other places that we frequent. So I could use Spatial Studio to help us find that. So we live in the state of New Hampshire, which is in the United States. And we're very lucky that New Hampshire provides a data set of all of the daycare locations in the state, including their addresses. And then I created a personalized CSV files of the locations that we're interested in. The data set that I'll show you today is fake, but it's based on reality. And then there's some things that we'll show you in Spatial Studio that I'll go through now to do that. So these are the different things that we're going to go through. So we're going to map the route using the driving route feature, return the shapes nearest one another using nearest neighbor, and then identify how far I can go from my quote unquote home in 15 minutes and create the shape. So why don't we just get started? All right, so I'm already in Spatial Studio. I already have my data set. So the green are all of the different daycares in, let's log in. Okay, log back in. So the green dots are all of the daycares in the state of New Hampshire. And then these blue dots are our pretend locations. So this is actually the Oracle office. This is where I'm pretending that my husband works. And this is another location that we're interested in that we would potentially want our daycare to be near or easy to get to. So the first thing that I'm going to do is find the driving. So the first thing I'm going to do is drop a pin near where our house or our potential house is. So I'm going to drop a pin here. And I'm going to do a route analysis to that. So I'm going to go to Analytics and hit Driving Route. And for each of our locations, I'm going to analyze the pin. Just give that a moment to work. Okay. And now I can drop these pins in, and it's a little difficult to see, so I'm going to go ahead and make that a little bit easier for us to look at. So I'll go in here into settings and change the color just to make it a little bit easier on our eyes. Okay. So that's the driving route that Spatial Studio identifies as the easiest route to get to these locations. Now that we have that, I can filter the shapes of the daycares to find the ones that are nearest the route that we're going to go. So to do that, we go back to Create Analysis, and I'm going to go to Filter and Return Shapes Nearest to Another. And I'm going to find the locations near the route geometry. Excuse me, I'm going to find the daycares near the route geometry. And I want to find maybe 20 daycares along those routes. And I'd like to find them within about 2 miles from the route. Now that we have that, I'll drop that in. And we can see that there are these little green dots that have, or these dots have turned green. So I'm going to make that, again, just a little bit easier for us to see. Excuse me, I said green, I meant purple. So I'll just make those a little bit easier to see, just to make our easier on our eyes. So, the other thing I wanted to do was add a little bit of information. So we can go in here and go to Interaction and use the info window. So when I touch on these buttons or on these dots, I can see a little bit more. So I might use the program name and the distance. So these two things would be valuable to me while I'm looking at these different daycares. And if I click on one of them, it tells me the name of the daycare and the distance from my route. So that's good, right? So I can go in here and look around and see, okay, these are the daycares that are closest to my route to work, or my husband's route to work, or this other area that I'm interested in. But we can do more than that, right? So we can go ahead and look at the driving reach. So the driving reach is going to tell me how far I can go from a location that I'm interested in. So I think it's pretty reasonable to say that I want to find a daycare within 15 minutes from our home. So to do that, I would go into here and go to Analytics and click Driving Reach. And I'll do that pin, which represents our home location. And I'm going to change this from 15 kilometers for 15 minutes, because of course we want to find a daycare that's easy to get to from our house, not just a work location. So maybe we work from home, and so that's helpful. And we'll drop that in. Okay, so this is the area that we're saying is about 15 minutes away from our location. I find the opacity a little high, so I'm going to drop that down so it's easier for us to now see the rest of the area. So Okay, so this is great. So I have all of these blue dots that are within the area that are also within this area, but maybe I want to make that even easier for us to see. So I can go back to our analysis and use a combine feature under spatial analysis operations and go to advanced and create a shape from overlapping area. And I'm going to do this twice so I can see two different types of intersections from here. So the first one I'm going to do is I'm going to get our drive time polygon, and I'm also going to get the route that we picked. And we can see the tolerance there, and I'm going to run that. And what that's going to do is highlight the parts of the route that are within our 15-minute area. Let's change the color for that. Running out of colors here. And I'm also going to do another analysis using the same operator to give us the drive time and the nearest neighbor. And what that's going to do is provide us all of the daycares that are simply within this 15-minute period, this 15-minute area. So I'm going to turn some stuff off to make it easier for us to see. And let's make this a different color so they're easier. Okay, so within these filters, I can now see the daycares that are easier or best. Oh wait, did I shut one off? I must have shut one off. I must have done something wrong. Let's just do that one more time and make sure that we click the right thing. Okay, so we're going to do the drive time polygon and nearest neighbor. This. It's 10 just to make sure. The benefits of doing a live demo, right? Okay, and here are all of the daycares that we should look at, which are within 15 minutes of our home and are along the route to our location. So if I go in here and change our interaction, I can get all that information that we had from before. And we can see some information. So this time, because of the type of interaction that we did, I can only see the ID, but that's really okay. That can give me enough information from there. So I can go in here and click on them, or more reasonably, I can just turn this back on and get that information. Okay, so does anybody have any questions? I don't see any questions in chat, but if you'd like to send me a message, I'm happy to show you that. But I just wanted to show you a quick demo of something that you can do easily in Spatial Studio. And hopefully you can take that along with you and apply it to your either personal or work life. Ramu, do you want me to introduce Gautam, or were you planning on doing so?
No, you can go ahead and do so.
Okay, great. So Gautam, thank you for being here and take it away.
Thanks, Denise. That's a great personalized demo where we also see a lot of good functional values as well for the different business use case. I'll be giving an overview of the latest and greatest of one of the geospatial capabilities, which is the native support for the geometry data type. So before starting to share my screen, I just wanted to set a context of what I'm going to show, which is basically the native support for geometry data type, which can leverage a lot of the capabilities what Dennis was showcasing as part of Spatial Studio. And it basically means we are now able to draw spatial objects as well as do geospatial calculations between the different spatial objects from within Oracle Analytics, be it a cloud version or be it a Oracle Analytics server. Both Oracle Analytics flavors now supports native support for geometry data type. And for today's session, I'm going to walk you through different examples, and I'm going to specifically start off with a fun example, which is more on one of the most iconic voyages of the ship Titanic, where I'll show you the different route maps and I'll show you how we have generated those route maps. And then we'll slowly move into different real world examples like transmission routes of undersea internet cables. We'll move into a specific use case on addressing climate risk to infrastructure. And if time permits, we'll also show you different canvases on how you can leverage the drive time polygons or ISO polygons that Dennis was showcasing as part of the Spatial Studio that we can now inherit within Oracle Analytics as well. And maybe one more canvas based on the time. So I'll now jump directly into the demo. Let me just get the Oracle Analytics Cloud. And like I highlighted, I'm not really sure if all the audience is aware of Oracle Analytics. So I'll be starting off with a very brief introduction on the different screens within Oracle Analytics. If you're not familiar with Oracle Analytics, this is how the introduction pane of Oracle Analytics looks like, where it gives the different users access to different dashboards for different data sets, based on which the users will be able to then either create the different canvases or based on their user security preferences, they'll be able to access the different dashboards as well. The very first example that I would like to show you is again the fictional mapping of one of the most iconic voyages, which is on the route map of Titanic. And I'm just going to open the canvas. I'll just give it a few seconds to render it on the screen. And as you can now see, it's now trying to render the route map of the ship Titanic, which is one of the fun projects that I was doing in parallel. And it's pretty much in detail wherein as I zoom in, we basically start off with the route between England and France. And we have also geotagged the different favorite scenes from the movie Titanic, where the exact geo coordinates of where Jack wins his tickets along with his friend and where they were boarding the ship. And then slowly we get into the route map as well. And as I zoom out, we can see clearly the route map between England and France. And from France, it picked up a few more people. And then it again went back to the Scotland area. As I zoom out, you can clearly see the route map between France and the different places. And then it ventured into the Atlantic Ocean. So as and when I move the cursor, we can go and have a look at the different scenes as well, where Jack attends the first class dinner and the different scenes like that. Now, what would be interesting is we could also get the actual roadmap of the iceberg that collided with the roadmap of Titanic. And if I have to show it to you, it's a very peculiar current in the Arctic side of it, which starts from the Greenland area. It comes like this. And at that particular moment, it was colliding with Titanic. So we have also geocoded the different scenes where they actually spot the Titanic and where they actually ring the warning bell, and then they try to deviate and the collision happens. Then you also have like the geotagged information of where Carpathia was spotted and where it rescued all the different survivors. And we have also included the route map of the unfinished route, which is basically what Carpathia did. And then, like you see, I mean, if you recollect from the movie, we have a very famous scene wherein when they near the city of New York, they are like trying to have a look at the Statue of Liberty, which is more like a symbol of resilience, and the actual port in which Titanic was supposed to end its journey, where Carpathia then ended the journey with the different survivors. In a nutshell, this is more like a fun project that we did by leveraging the native support for the geometry data type. So now, just to show you how a geometry data looks like, I'm going to click on this data tab, which gives me some extra capabilities to look at how the data looks like. So this is one of the spreadsheets that I have imported with a very specific geometry data type by the name well-known text, which is again a specific type of geometry type that we support. And if you look at this specific, you can see that. I mean, you might be familiar with data types like attribute or numerical formats. We now have a very specific attribute called as geometry data type, and it will be appearing with this globe and location symbol. And you would notice that every entry for all the rows has a entry called geometry, which is not really in the human readable form because it's a spatial data object. And if you need to understand more about the spatial data object, Oracle Analytics also provide a very specific geospatial calculation. So if I expand the pane, this is the data set, which is basically drawing the route. And I can write a calculation here. So I have this geometry data type called as route map, which is what is rendering the entire route of Titanic as well as the iceberg. And I can now write a calculation called as geometry as text. And I can just select the route map, which is the geometry data type column name. And I'll just give it a name here and click on the save button. And now you would see that it has created a calculation based on the geometry data type, and I can just drag and drop it to the canvas. And you would see that the geometry data type, which you could see here in a not so human readable format, is now translated into human readable format. It's basically following a format called as line string, which is how you basically draw a series of lines or a set of lines and then have it rendered within the map visual. I can probably add my route description here to give it a more detailed view. So for, let's say, the England to France. So if I have to go back to the visual, all right, so if I go back to this visual here, you have this England to France stretch here. It is basically one line string, which is how it is represented using the calculation, which is shown here. So this calculation is drawing that set of lines. So you have one set of lines for England to France, then you have it for France to Ireland, then you have the Ireland to America, which is where the collision happens, and the different lines as well. So in a nutshell, this is how you would typically understand a series of lines within Oracle Analytics using the geometry data type. And just in case, if you're interested in knowing how we actually do the route map, like I was highlighting, it's a hand-drawn map. And if you want to do some fun projects like this, you can also visit websites like wktmap.com, which are like open websites, which allows you to draw the routes as well. So, for example, if I have to simulate what I did here, I can go to one of these port area and let's say, let me select a line here. And this is just an example. So I can draw it like this. And the moment I double click, it gives this line string here. So what I basically did, I drew this by hand through the different routes using open websites like wktmap.com. And you can just directly copy paste it to a spreadsheet, or you can bring it to the database as well. And once you bring it into Oracle Analytics, you basically then get to visualize this in the geometry format. So this is one of the example. And if I have to now progress with a set of different examples, I'll again log in back to my Oracle Analytics instance. This time I'm going to also show you how to navigate to different folder structures. So what we earlier saw was the introduction screen from where you can call the different dashboards for how you get to create different dashboards using the favorite datasets that you have access to. Now, if you want to access the different dashboards that is in a shared folder, so different users may be having access to different types of folders here. So in this case, I have created a shared folder called Austin for today's session, and I'm going to just open that where I have all the different dashboards already saved that I can use as part of today's session. So the next example that I'm going to show is a very familiar example, which is on the undersea internet cables. And it is again, let's say if I have to probably take a step back. So in the last example, we were showing you a technique wherein you can draw the routes by hand, but it may be possible that you will get a set of spatial files from the internet, which you can then convert to geometry data type as well. So this is such an example wherein what we are essentially looking at is a set of undersea internet cables, which basically transmits the internet throughout the globe and through which the different cloud regions get access to the different instances that we owe, or this is basically the reason why the different geographies are able to connect to internet and then help customers to reach their data as well. So like how the canvas name says, data from cloud through ocean to you. It basically illustrates how the internet is transmitting through ocean that connects the different geographies. And in this specific example, what we want to highlight here is we basically received this shape as a GeoJSON file, and we can then use open source tools like QGIS or maybe Python scripts to convert GeoJSON into a spreadsheet that will convert the shape from the GeoJSON file into a well-known text format, and you bring it into Oracle Analytics, and you'll be able to directly illustrate the map. Illustrate the line within the map as well, and then it gets interactive, wherein you get to let's say import different layers and then overlay on top of different layers. So in this specific example, we have the set of undersea cables, and I've then layered it with all the information from an Oracle Cloud Infrastructure perspective. So if I zoom out, these are all the different commercial cloud regions that we have available as part of our global OCI portfolio. And it's interactive, wherein you can go and hover over the different points. The tooltip allows you to look at all the details. Let's say if I want to identify all the Oracle autonomous databases that are available as part of the different Microsoft cloud regions, I can just click on the Oracle database at Azure. So these are basically all the different regions where we have autonomous database availability within the Microsoft cloud. Or you also have the Oracle database. I think it's not autonomous database, it's Oracle database that is available within the Microsoft Azure. And you can also look at all the different flavors like Oracle database, which can be deployed within Google Cloud. And similarly, all the dedicated region, where all we have the EU sovereign region, where all we have the government related centers. So this canvas basically illustrates all the availability of the different types of Oracle Cloud regions, and also illustrates the different undersea internet cables. And this is again leveraging the geometry data type that we saw in the earlier example. So if I have to expand this, we have the geometry data type called C cables, which is basically line string. So if I have to do the same calculation, it will give you line string. And similarly, under OCI region, I have the OCI region as well. So if I have to create a calculation for my OCI region, you will see the second flavor of it. So let's say if I do geometry as text and then just select my OCI regions and click on the save, and I'll probably use a different canvas here, and I can drag and drop the calculation. So you would notice that in the earlier example, I was having it like, so if I go here, this show it as a line string, which is one of the supported formats within geometry data type. But in here, you can see that it's a point, and the next example is a polygon, which we will show in the next example. In a nutshell, we just wanted to highlight we support different flavors of geometry data type. It could be point, it could be lines, it could be polygons. And once you have the different layers of geometry data types brought into Oracle Analytics, you will then be able to visualize all these layers on top of each other using Oracle Analytics. Now I'm going to go into the third example, wherein we'll be looking at a bit more detail. We'll be showcasing the different geospatial calculations as well. So like how we did earlier, I'm just going to navigate myself into the shared folder. I'm going to Austin. And this specific canvas might take few seconds because we are also leveraging a lot of geospatial calculations. The theme behind this canvas is how to address climate risk to infrastructure and how to leverage the different geometry data type as well as geometry calculations to come up with a canvas with advanced insights as well. So this specific canvas, like I highlighted, since it's basically addressing the climate risk, I've got many different data here. So this is one of the examples of the polygons. Earlier, we were looking at lines and points. And if you look at this specific example, this is a location in the south side of India where we have all the different shapes of the national parks, which is represented through polygons as a geometry data type. We have different data like you have the data on the different high voltage power lines that are passing through the different districts of the same state. I've got details on the latest wildfire incidents that has happened. It's actually a collective information from the last 5 years, which is now a point. So if you look at these three geometry data types, one is represented through a polygon. This specific set of shapes are getting represented through lines. And the third one, which I'm focusing on the wildfire incident, is actually a point data type. So all three are like geometry data types. And now you can also bring in advanced shapes. So we basically got a shape file, which is a second file. So in one of the earlier examples on the undersea cable, we are highlighting that you get to convert a GeoJSON into a geometry data type using well-known text. Very similarly, in this case, we converted a shape file into a well-known text format, and we directly imported in Oracle Analytics as a geometry data type. And it's basically showing how one of the largest rivers within the state is represented. Now, I've also got information on the flood affected areas from the various government sources. And now, once I have all the static information on, let's say, national parks, high voltage power lines, wildfire incidents, the rivers, or the flood affected areas, Oracle Analytics now allows you to write geospatial calculations as well. So based on all the information that I have above, I'm then able to come up with canvases like I can easily identify only those national parks through which the different power lines are getting connected. Or let's say I can easily identify all the national parks where wildfire incidents happen. So this may not really have any connection between the wildfire and the national parks. When we import the data set, it might be different, but then we are able to do certain Cartesian join using the data preparation available within Oracle Analytics. We are able to make relations between the different data sets, and then by leveraging the geospatial calculations, you'll be able to calculate only those national parks where wildfire incidents happens. And very similarly, we can also identify power lines that are like very dangerously close to the different wildfires. And one last example on the geospatial calculation, we can also identify the different power lines that could be passing through the flood affected area. So the difference here is like one is on the wildfire. So for a wildfire, it might be dangerous that the electric lines are passing very close by, and we can easily identify that. The exact opposite scenario with the flood affected area. So with the flood affected area passing through largest rivers in the world, it might be very helpful to identify only those power lines that are passing through the flood affected area so that they can make corrective action. So say for example, in a flood affected area, like if the power lines are up and running with very high voltages, it might be transmitted through the water, which might be causing a big or bad calamity to the different areas. And using these geospatial visualizations as well as geospatial calculations, you will able to identify these insights and then be able to address it much in front of the hazards as well. Now, to show you how we have done these calculations, we again open this My Calculations area within Oracle Analytics. I'll also show you how to create a calculation. You have an add button here. You have an option called as create calculation. And on the right-hand side, these are the different types of calculations that are supported within Oracle Analytics. And we now have a very specific feature called as Spatial, under which you have like different types of spatial calculations. So geometry area can calculate the area of a geometry shape. Geometry distance can calculate the distance of a distance between two geometric shapes. Geometry length can calculate the length of a geometry shape. Now, geometry relate is something which we can use to identify whether one shape is related to another. So, to quote as an example, I'm trying to highlight here. So, say for example, this power line is passing through this specific national park. So, there is a relation between the national park and the power line, which basically says the power line is related to the national park, and I'm able to identify it using the geometry calculation. The last calculation that we have in the spatial is geometry within distance. So if I want to identify whether a geometry shape is within a very specific distance of a second geometry shape, I'm able to call in this geometry within distance as well. To actually show you how we have done it, let's say I'll just take this as an example. So this says power lines that are dangerously close to wildfires, and I can open this specific within distance. I have used it in one of the filter, and if I click on this modify filter, you can see that I have only selected all those power lines that satisfies the criteria as true. I have not really selected the false one. Reason being, if I edit this calculation, it says geometry within distance. I'm selecting my wildfire location, and I'm then selecting my power lines, and I'm then telling only identify those power lines that are in a range of 10 kilometer. It could be 25 kilometer, it could be 50 kilometer. And in this case, I just want to find out like which all um, power lines are dangerously close to the wildfires. In the second example, we have it at like 50 kilometer where we are trying to identify the power lines related to the flood area. So um, uh, based on our requirement, we'll be able to override these numbers as well, which I'll be showcasing in my next example. So just want to possibly take a brief. Any questions at this point of time? I don't see anything in the chat. Or maybe for David, if I have missed anything from a geometry data type perspective, feel free to add as well from your side.
Yep. No, it's looking great.
Yeah, all right. In which case, I'll now move into the second flavor of it. So the reason why I'm calling it a second flavor, during all the earlier projects, I was in fact showcasing the support for native geometry data type from a spreadsheet perspective, wherein like you get to import a very specific data format called as well-known text, which is supported through the CSVs that we can import directly into Oracle Analytics without any additional configuration. The next set of canvas is going to focus specifically on the SDO geometry, the spatial data object geometry types, which is how you natively draw or do the calculations within an Oracle database, or let's say the autonomous database as well. The next set is based on that. And in this specific example, I'm also going to show you how you can call drive time polygons or ISO polygons both statically as well as dynamically using Oracle Analytics, which is what Dennis was showcasing through Spatial Studio. So like earlier, I'm going to navigate myself into the shape folder and go to Aston. Let me open the specific canvas. In this example, I'm leveraging the SDO geometry, which is basically what we have in an Oracle database. And I'll highlight the different flavors of doing the geospatial calculations as well as the drive time polygons. So I'll probably need to open just one more canvas just to give a bit more detail on the geospatial calculations. So let it just open. It's a very similar canvas with the same data. All right. So if I go back here, what this canvas basically has, it has got a list of customer assets, and it also has, let's say, a storm path, and we have also drawn a buffer around the storm path, which basically indicates all the customer assets that falls within that specific buffer in relation to the storm line is going to be at risk, and you'll be able to identify all these uh, assets at risk through geospatial calculations or by manually selecting it as well. So the first part of it is to again show you how you can leverage the geospatial calculations to identify the different customer assets at risk. And if I have to navigate back to this specific canvas, it's the same visual. If I expand it, we have the map of United States. We have different points, and these points are represented. If I open this, you have got this GC underscore geometry, which is the geometry data type, which is visualizing the different coordinates or the latitude and longitude converted as a geometry data type. And then you also have the storm path by the geometry column called geo. So the blue line that you're seeing here, that's basically the storm path, which is again a line string converted as a geometry data type, and you have a set of points as well. Now, if I want to do some calculations based on, let's say, identify only those customer assets from this map, which satisfies a very specific criterion, I can go to the second canvas here, where you see that there are less customer assets involved because it has basically identified only those customer assets which are at risk within a very specific distance. If I expand my calculations, I have a calculation by the name within range, and if I edit the calculation, it basically triggers the geometry within distance spatial calculations. I've selected the storm path, and I've selected the list of points, which are basically the different customer assets. And I'm trying to identify, or I'm trying to specifically identify those customer assets that are in a range of 350 kilometers from the storm path. And the moment I drag it to my filter, I can click on this modify filter, and it gives me the true or false. It basically means all the customer assets that satisfies the criteria true, and all the customer assets that satisfies the criteria false. So say, for example, I uncheck true, and if I click on the false, it will then try to render all the customers that are maybe farther than the 350. Say, for example, these customer assets are basically outside the criteria that we wanted to identify as an insights. So now if I move back to this specific canvas, it's the same canvas where we have the different customer assets, the storm path, we have the buffer as well. And this is where we want to highlight the concept of the session variables. So within Oracle Analytics, we have the concept of what we call as a semantic model. And a semantic model allows you to do some logical modeling on top of the different database tables that we have as part of the autonomous database or a traditional Oracle database. It could be an on-premise version as well. And semantic model allows you to do logical modeling, trying to do the different joins as well. Now, once I have the semantic model ready, I can then also call different session variables, which is a concept within Oracle Analytics. So say, for example, I want to modify the parameter for this specific buffer. By default, it's taking 100 kilometers as a range from within the storm path. And let's say if I now type in 50 as kilometer, and when I click on apply on this specific canvas, it basically try to override. So you see that the buffer distance is now reduced. So say, for example, if I want to increase this buffer as 350, I can input this number, I can click on apply, and then it basically increases the overall size of the buffer. So you now see that there are like, the buffer is now much higher. So let me now reset it to 100, which is the default value, and I click on apply here. And it again resets the buffer size. And now what we want to showcase is basically something what Dennis was highlighting through Spatial Studio. So say, for example, you have this dashboarding capabilities, and I'm going to handpick probably, let's say, if I go here. So if I look at this specific customer assets, it's like dangerously close to um, the stone park. Now, it could be a customer asset, or it could be an apartment, or it could be a very specific street area. And say, for example, in case of risky elements, if the police or if the fire department has identified a rescue location, we have the capability to also draw the routing or the drive time ISO polygons using dynamic session variables. So let's say, for example, we have identified this ID with 36, and I can now just right click here. I can click on copy data. Let's say if I bring this to my notepad. So I'm this, and I'm going to enter this address, and I can click on my apply here. And now you see that just like how Dennis was showcasing it in Spatial Studio, I was just able to input my country as well as a manual address, and it has identified a buffer or the drive time area of how long I can drive within 30 minutes of drive time from that specific center of source. And now if I go back to my notepad, so I can also identify the drive time polygon or the routing. So I am going to go back to my place here. I'll just copy the source address here. Go back here. I can take this as my target address. I give both. Now I'm clicking on the apply. So now you can see that it has identified the uh, driving distance or the driving route between the source and the target, which could be like a rescue center. In this example, I've just taken the example of one of the church from that specific area, and we can see that it's still within the striking distance of that 30 minutes time frame. So it might be very vital that you have to identify whether the routing is within a very satisfying distance so that the fire department or the police department will be able to do the rescue and make sure everything is still in control as well. So this is an example where we could really highlight how to make it dynamic by bringing in session variables or semantic model concepts. And these are all calling SQL functions back into the Oracle database or an autonomous database and then coming back with the results, which then gets represented through a geometry data type and then gets illustrated on the Oracle Analytics. So just to show it as an example, if I expand this driving distance, you have a location pin. So the green dot that I have here, it's basically a geocoding mechanism through Oracle database that represent this information on the map. You also have like a driving distance polygon. So the polygon that I'm highlighting here, it's basically getting illustrated using this drive area. We have the different other geometry data types, which are again all spatial data objects that are coming directly from the Oracle database without any additional configuration or map layers. They're all geometric data types that are overlaid one on top of each other. So if I expand this, we have like different capabilities here wherein you will be able to stack the different layers one on top of each other, and you will be able to then trigger all these different geospatial calculations as well. But just in the interest of time, I'm just going to wind up with a very simple example, just focusing on the spatial data object. So I'm going to the catalog. I'm going to the shades folder once again, the Aston. So I'll open this. So if you recollect, we were showcasing a very specific examples on wildfires, power lines, which were doing the calculations using well-known text, which is a very specific geometry data type through the spreadsheets. And this specific example that I'm going to showcase is a similar example on how you can leverage the same calculations and then trigger it directly through a Oracle database in the traditional database. So if you look at this, I've got different calculations here. You are relating. So you have the US map, you have the different counties. I have the storm path. So these are like static information that we have on the left and on the right. We basically leverage geometry relate calculations. So it basically just identified only those counties that are inside or that are touching the borders of the storm path. And very similarly, you also identified only those counties that are in a range of 350 kilometers using the geometry within distance. So if the data is residing in the database, you will still be able to execute all these spatial data calculations and then overlay it on top of each other. And yeah, I mean, just to recap, I just wanted to highlight, so Oracle Analytics now supports native geometry data type through which you will be able to visualize everything. You will be able to do the geospatial calculations. And maybe one small thing that I forgot, let's say you have like different data sets coming in. And this goes back to the power line example. If I click on open here, all right. So let's say I had the power lines, I had the wildfires, the flood areas, the river-related routes, the national parks. So Oracle Analytics also has this data preparation area where you'll be able to do the Cartesian join, which is one of the mandatory steps. I just want to highlight, if you want to do geospatial calculations, you would need to also establish a Cartesian join between the different data sets. In this case, I'm using the IDs between the power lines and the river, or if I have to identify which all wildfires are very close to a power line, I'm using a Cartesian join here as well. So this is an area where you get to do the different spatial Cartesian joins, and it remains the same for here as well. When I click on data, I can go to one of these data editors, and you would see that we have established the Cartesian join between the different data sets as well. So if I expand this is through the database where you have done the Cartesian join using the IDs, using which you are able to do the geospatial calculations. With that, I wind up my session. So I hope it was interesting.
Gautam, one thing you might want to mention, I don't see any questions in there, but that was really, really nice work. It looks great. You might want to mention about the geocoding and the routing, the when you were doing SQL-based operations for those, that those are running on autonomous. So that's a sort of
Oh,
there's
yeah.
a restriction on the database environment that's available on.
Yes, very, very valid point. So this example, where we drew the different drive time area and the routing, yeah, it's not yet there in Oracle traditional database. It's possible only through the autonomous database. Yeah, thanks for that, Dave.
And yeah, I don't see any questions right now, and I think we are right at the top of the hour, Ramu. So I think we should probably bring it to a close.
Yes, awesome. Thank you everyone for attending. And again, we do have our next session, April 29th. So hope to see you there and have a great week. Bye, everyone.